Good day, everyone. Thanks for joining me on this presentation and demonstration of quite an interesting new topic and process of cost and time-driven parametric design in construction. My name is Mile Tepejovic. I'm an architect and senior BIM manager at BEXEL Consulting. Today, I will try to present you with the latest approach and new ways of project analysis and design management, which are extremely valuable and can be used in very early stages of any project. Now, using the potential of BIM tools for parametric and generative design options, we can explore hundreds of ideas, and in a combination of BEXEL Manager and these platforms, we can explore all generated options and find the best possible solution. All these innovative workflows which will be presented are based on the Open BIM standards and are using IFC for information exchange. For those of you who don't know our platform or not familiar with the BEXEL Consulting, our platform won buildingSMART Innovation Award in last year's competition, and we are very proud of that accomplishment. And this just gives us a new motivation to go even further and explore an even more innovative and futuristic approach in our industry. The next video can be introduction to this presentation, and hopefully it will give you an insight into our capabilities, future development of BIM management platforms, and new perspectives on construction automation, and let's say a glimpse of possible services in Industry 4.0.
Utilizing artificial intelligence algorithms, BEXEL Manager allows you to comprehensively analyze dozens of what-if scenarios. Engineers can now study multiple design alternatives in real time, having more freedom for innovation, optimization and higher quality. In synergy with parametric design tools, BEXEL Manager brings the next generation of data-driven decision-making. Our advanced workflow employs smart technology and applies captured experts' logic to generate construction schedules, project budgets, cash flows and resource requirements for each of your preferred solutions. This way you can estimate project key design indicators together with required delivery time, cost and cash flow, and choose the best option.
As you may see, the car industry, automotive industry, already using parametric design for designing new parts, which are more reliable, economical, more durable, and more efficient. And practically entire industrial design uses it. The plane industry also uses it for designing specific elements or plane parts such as wings, plane body, and so on. And the boat industry, sport equipment, shoe industry, furniture industry, and even toy industry using it. All have great benefits and all have already embraced the potential of parametric and generative design. In short, parametric design is an interactive process that allows you to create designs based on the input parameters. The parameters could be quite simple as basic dimensions of the building such as length, width, height, or more comprehensive such as site constraints, site density, open space, people circulation, or environmental issues such as daylight, acoustic, people density, or similar. That allows engineers to make design changes in real time, and since the software updates the model automatically. So the approach, this new approach actually, allows you to explore many more options before deciding on the final design. A generative design could be in a way considered as an extension of parametric design since it relies on defined input parameters. But instead of just creating the output in one iteration, it combines parametric design input parameters, which are predefined, and computer power and also artificial intelligence to find the best solution in multiple iterations. Firstly, designers need to set constraints and goals for very clear and proper way, actually, to make the entire process successful. They also need to provide metrics to rank each result. So in the following slide, you may see that the last few years we do have a huge improvement and a growing number of parametric and generative design platforms which are used or specifically made to facilitate and improve construction and urban planning design. The entire process of generative design is iterative and uses advanced algorithms, so when the software delivers results, it uses previously provided evolution metrics and ranks all results. Depending on solution and artificial intelligence algorithms, it starts by rejecting the low score solutions, and after that it creates another set of solutions based on the features with the highest score. And this approach allows designers to test hundreds or thousands of options and find the optimal solution based on predefined scoring metrics. Engineers now can set parameters and result metrics, and the computer will actually do the rest of the job. This gives us more freedom for innovation and optimization, and similarly, as software engineers run code for try and catch exercise, now designers can actually test numerous solutions until they find the optimal design result. The same process can be applied to design low-scale environments such as buildings, but it also can be used for a large-scale project such as city quarters or even entire cities. We believe that the perfect combination in the everyday construction industry would be a mix of generative design results and comprehensive BIM analysis for cost and scheduling that can be achieved even now using BEXEL Manager Intelligent Schedule Engine and combination of different generative design tools. Using a synergy of these platforms, managers, designers, and clients can analyze and study multiple instances of construction simulations along with the respective cost, resources, and quantity data, and the automation of quality control increases accuracy, and automation of repetitive and time-consuming tasks increases overall productivity and unleashes creativity and space for even more innovation. So the process map on this slide explains the workflow of the cost and time-driven analysis. After the completion of the parametric or generative design processes, we simply select design results and get them through our BEXEL Manager integrated BIM platform using something that we call 5D in 5-step process. So firstly, we can verify BIM data using simple or advanced quality control tools. The following steps are quantification, BIM-based creating cost database, and then a calculation of cost estimation. Lastly, we define spatial and constructional dependencies using our zone and methodology editor tools for schedules. The system then intelligently using BIM data or BIM model elements and mix zone and schedule relations and dependencies to automatically generate entire construction schedules and 5D construction simulations. So resulted schedules are evaluated with the respective resource and cost data, and then the process is repeated for multiple generative design results. In the end, we can compare and analyze different 5D outputs for different design results and select the best one. Now I will present you a part of the script which is used for generative design in this case study. And as you may see, the Dynamo script is quite comprehensive and is based on basic parameters such as length, width, grid, level height, and number of the levels, as well as rotation of the stories and building on the site and rotation of each story. Based on that, we can automatically generate our building. What is really important here is that we want to analyze gross floor area and facade surface area for each result. And these are actually resulting metrics that will be used for comparison of multiple solutions. Instead of repeating the process and change input parameters hundreds of times, I will set a range for input parameters and run the engine for generative design. The system will run the script, or will run multiple scripts with a multiple variation of the input parameters. The system is processing the data and sorting it so we can go through multiple variations. The results are listed and the engine is placing all different outcomes into space. After completion, we have a variety of solution options that are different from one another, and now we can analyze specific outcome results, or we can even filter or sort all these results based on specific outcome results that we specified at the beginning as a metric. In our case, I filtered results within the range of 20,000 up to 25,000 square meters of gross area, so we can decide which solution is best, or let's say more suitable for our case. Now, when the generative design platform is completed, from almost 200 different outcomes using the filtering option, we decided to select only 6 different results with the relatively similar gross floor area in a range between 22 and 23,000 square meters. Now, when we have the first set of building solutions, I'll explain the process of cost estimation and generation of different versions of 5D construction simulations using these results and our advanced scheduling engine within the BEXEL manager. I would like to point out that we could use just these created masses for the entire cost and time estimation, but in order to test the solution even further or make them more believable, even though it's just conceptual stage of the project, we'll use the same script which I presented previously to generate structural elements and apply more detailed construction systems and analysis in more detailed level for cost estimation and variations. The script will instantly generate main predefined structural elements such as foundations, slabs, beams, walls and columns, and even basic architectural elements for facade and spaces. These spaces are just simple rooms for the entire story, or in some cases 2 or 3 generative simple room covering the entire area of one level. But these results can be very quickly reviewed using quantity takeoff analysis, where custom breakdown structure are also generated based on the IFC building types. Previously mentioned spaces, or to be more precise, placeholders for the rooms, are also quantified and then will be used for cost estimation of, for example, MEP works and finishing architectural works using the square foot calculation method. Since in this stage of design, engineers usually work with a very simplified model, the areas are really important, and these rooms can be used instead of MEP elements for further design stages. The quantity takeoff results are exported, and the same can be then used for further comparisons or the creation of BIM-based cost databases. These multiple building options and results of quantity takeoff calculations are a great source of timely information and insight on the first drafts of structural and architectural design. Using the outcomes, it's very easy for all participants in the project to identify valuable information and to provide feedback to design teams for additional modification or additional optimizations. As you can see, using these very quick QTO analysis and exports, engineers have full knowledge not just about the shape and the static of a proposed solution, but also measurable differences and clear picture about the possible impact of each design option on the final cost. And more about that topic will be covered a little bit later. So using visually presented results, which can be exported in Excel spreadsheets or Power BI templates, the manager and clients can identify pros and cons for each of the generated solution, number of levels, gross floor areas, facade areas of each design option, and of course quantities of main structural elements. Again, I remind you that we still talk about almost instant analysis and comparisons of 6 different design solutions almost in real time. One of the greatest benefits of BIM, which represents single source of truth or one centralized information database connected to model geometry, is that we can easily extract the information, analyze it, and organize it in other ways according to our needs or according to specific requirements for the project. Our platform uses all existing BIM data, and in this case, for example, IFC property sets, to segregate BIM elements into cost breakdown structures or into elements which can be used for cost breakdown structures. This slide on a high level explains the process of using BIM data to create cost databases and calculate cost estimation of your projects. Using the existing model and respective BIM data, we can automatically organize elements according to any property or its values and use the structure for a base of future cost database. Once the cost breakdown structure is created, users then can specify and define additional information for cost database such as unit price, resources, or calculation formulas. I will demonstrate the same process in a live demo using one of the previously filtered design results. We can use the existing quantity takeoff structure to create our cost structure. Using different IFC building elements, for example, the system creates cost items that already have defined linking rule with model elements for later cost and quantification calculation. The fastest way to edit the cost database and create additional cost items for calculating the price of elements which are not existing in a BIM model in early stages of design, such as formworks, reinforcement, MEP systems, or even interior design elements and architectural finishing layers, is by editing this in Excel files. In the exported file, we'll use the data of existing elements, for example, concrete beams and slabs, to create cost items for reinforcement and formworks, using custom formulas to accurately calculate their price. For the rest of the cost items, which are mainly related to MEP and which are also don't exist in this model in these early stages, we'll use existing spaces or rooms in the model and make cost items that will calculate the price based on the areas of existing spaces using square foot method. Once we enter the unit price and the entire database is defined, we can then import back this Excel file or Excel cost database and use it for cost estimation within the BEXEL manager, and apply cost estimation engine for auto-linking BIM elements and cost data to automatically calculate the cost version. As you may see, the entire cost version is created and all the prices are calculated automatically, including reinforcement or price for anticipated MEP works. Even though we didn't have these elements modeled in the BIM model, we used existing room elements to calculate the entire cost versions, including MEP, and calculate the entire cost version for the project. The great thing here is that existing cost database can be reused to calculate the price of other versions of the same building, since they all were generated using the same template file and the same script. So once the cost database is defined, we can use the same cost database for our scheduling engine and to generate a schedule and multiple versions of a schedule to test our construction simulations for the project. The important thing here is to interpret the scheduling logic of the planners which they're using for methodology, and this will be achieved using our methodology tool and then apply it. I'm not going to explain everything in detail, but if you're not familiar with our platform, the core of our engine is the ability to intelligently interpret predefined schedule hierarchy, structure, relations, and schedule sequencing in form of methodologies. The system then combines methodologies with spatial information from a model defined within a zones, and then almost instantly creates thousands of tasks following that predefined logic, relations, and dependencies between schedule items. On the same project example which we previously showed, using the scheduling engine, we specify sequencing and dependencies of schedule items using methodology tool. These planning methodology items relations can be defined in multiple hierarchy levels. As you may see, all methodology items are linked to respective cost items from created cost database, and on other hand, using the zoning tool, we specify spatial sequencing and are teaching the system how the methodology items will be spread out through our levels and building zones. Now, mixing zones and methodologies, we can create multiple schedule creation templates, and these allow us to generate entire schedules in a matter of seconds. All these templates are exchangeable and reusable in other similar projects. And now you may see how generated 5D simulation looks like almost instantly. And note that the entire cost is also presented, and all MEP works are executed in form of execution of specific rooms in our animation. Sometimes the first schedule is not ideal, of course, so we can always try different options or try to optimize the existing ones. The hardest part, which is creating all these relations and related tasks, is done by our intelligent engine. And in our case, we created another schedule template by defining different methodology, which is frequently used on a high-rise project where the execution of concrete core or the core of the building is the leading activity, and all other activities are more or less dependent on the pace of core execution. So you may see how easy is to create another version of a schedule and preview 5D simulation for it. Different versions can be compared and analyzed within the platform itself, or exported into Excel files or Power BI reports for further and more detailed analysis and comparisons with other projects or project versions. Another benefit which is really important here is that all created methodologies, schedule templates, and cost databases can be exchanged and reused for different projects or in our case for different versions of the building. To present you multiple use cases and scenarios, this process again on high level explains what is possible once you use our scheduling engine and create first schedule. A generated schedule or schedules can be easily adjusted or optimized, and planners can use and apply multiple calendars on multiple tasks and change duration of specific tasks or entire schedule. And then the common question is when we talk about BIM-based schedule is can we add new tasks which are not related sometimes to any model elements, and how these scheduled tasks will be presented in 5D simulation? So the simple answer to this is yes, of course you can even add additional tasks which are not related to any BIM model element, but you can link them with your cost items and calculate the price for these activities even though they're not related to any BIM model element. And of course you can even make these tasks time dependable, so the price is changed when duration of these tasks is changed. This could be very handy when we talk about, for example, tasks for management services, site surveying services, or other design and engineering services which are almost never exist in a BIM model. The system really provides comprehensive and very advanced options to professionally develop very detailed schedules. And don't forget that we still talk about the concept design, very early stages, and analyzing multiple design options. The best thing now is when it comes to cost estimation of generative design solutions and exploring different construction schedules is that all previously generated data is exchangeable, and we can simply import our previously defined methodologies, template, and cost databases. Using the auto-assign option, engine applies previously imported cost items, cost databases, links them with model elements, and calculates the total price. In a matter of minutes, actually, we have new cost estimation for totally different building or for a totally different new design solution. Additionally, we can analyze each part of the building price for different disciplines or different building zones. Similarly, as the cost is automatically calculated using our scheduling engine, we can create new schedule version for this building using imported and predefined construction templates. So the entire schedule is created with respective links and relations, and now we can preview full 5D simulations. Planners and manager doesn't have to spend days and days analyzing quantities and design options in order to create different variations or different versions of schedules for each building, and then additionally make construction simulations. We believe that new technologies and new workflows allow us to be more efficient, more productive, and on top of that more accurate, using possibilities of integrated BIM platforms where all the data can be easily analyzed, reused, edited, and exchanged. And due to the time limitation of this presentation, I won't go into details and repeat the same process for each of our 6 building options, but I will present you the outcomes of previous workflows and analysis. After loading cost database and schedule generation templates into each of these projects, once executed, The system creates cost estimation for each solution, and based on our predefined calculation formulas and based on different design options from model itself. The same predefined planning methodology for cast-in-place construction is applied to all 6 solutions, and you may see the outcome 5D simulations here. Duration of each simulation video corresponds to the real-time execution of that building. Again, in the very early stages of the project, these types of cost and schedule analysis can be extremely valuable for the investors and later on for the project managers as well. Exported cost and time information in form of Excel spreadsheets directly from BEXEL Manager platform allow us to easily compare all the options, visualize results, and analyze the pros and cons of each solution. As expected, the tallest solution will take more time to be executed, but the price of this solution is not as what we would tell just from the look of the design itself. Exported cash flow charts can give us some insight on initial expenses, especially important for investors and future project managers, so they can anticipate material procurement, paying salaries, fund new projects, and finance other functions of the company's operations and so on. It's also very interesting to the contractors. They can understand the risks and potential benefits of hiring subcontractors on the project and in which phase of the project they would hire the subcontractors. In this case study, even though the price of solutions 3 and solution 4 are not the most economical, we decided that their layout and height comply with the site regulations, and that design of these 2 options is very interesting compared to previous design options. So we'll continue to explore some additional design or optimization options even further for these 2 options. And the first thing which comes to mind is to try with a prefabricated type of construction, at least for structural elements, and explore results. Again, since the entire building is generated using a parametric design, just by editing the script, we can create and update model presenting prefabricated structural elements. Created versions are loaded into our platform, and since the model is still very low level of detail, you can see that only difference in structural elements is the subdivision of structural slabs into prefabricated elements. In this iteration, all quantities are the same in both versions, cast-in-place and prefabricated versions. Only the number of slab elements is increased due to the subdivision. However, the cost items for prefabricated elements and the price of their installing is different. So the easiest way to create new cost database for prefabricated elements is by editing the existing one or traditional cast-in-place construction, and instead of existing cost items for formwork, reinforcement, and concrete pouring, we'll just specify new ones, delete previous, and define cost items for installing of respective structural elements. The same process can be done in Excel sheets as well, and Excel files can be easily exchanged also. After providing the unit price and calculation method, the cost database can be loaded again, and the system will automatically calculate the price using the already explained auto-assigned engine. Once the price is calculated, users can explore price of selected elements and compare price differences when the elements is executed as a cast-in-place or when the elements are installed as prefabricated elements. The next step in order to explore a prefabricated method of construction, we need to adjust existing schedule methodology used for custom placed and modify it for prefabricated sequencing. In this early stage of a project, the main difference between prefabricated and custom place scheduling method is that prefabricated scheduling methodology doesn't have a second level of methodology where formwork, reinforcement, and concrete pouring are defined. So instead of that, we'll use only the first level of methodology with minor changes of dependencies between methodology items. And once the predefined creation template for schedule is executed, the entire schedule for prefabricated construction is generated. The same can be reviewed as a 5D simulation, and all respective schedule reports can be also accessed and reviewed or even compared with the custom place scheduling options. Of course, all schedule reports can be exported into Excel sheets for further analysis. Created 5D simulations can be exported and outcome results can be analyzed side by side so decision makers can have all necessary insights and information needed to make the right call. As you may see, just the small adjustments in a model have a significant impact on the total price of the final solution. Duration of prefabricated schedule is also shorter, and even though the quantity of structural elements is the same, the number of activities is smaller and the time needed to install prefabricated elements on site is notably shorter. All charts and reports are instantly generated and exported, and using exported results for comparisons, it's clear that prefabricated construction method is the preferable one for this project at least. So price of structural elements is around 20% decreased and schedule duration is almost 30% shorter as well. From the presented results is quite obvious that this exercise of testing prefabricated construction gave some results, and now the price of solution is comparable to the other previously explored solutions which were cheaper in the first place. Now we can go even further and try to test additional optimization such as facade change. Initially, the facade for entire building is generated using a parametric algorithm for creating randomized facade subdivision patterns and using predefined panels. Initially, we used 4 different panels, but if we want to test other scenarios using the same script, we can generate a simple version using, for example, only 3 different panels, or even use just one panel to create a common curtain wall facade as the third option. Just by changing facade patterns and panels, the facade area is still unchanged, but the number of the panels, their price and materials are changed, and these changes can be easily tested for further implications on cost and schedule. So going through all options, you can confirm the accuracy of the data and explore the impact of these results to cash flow, for example. The simplest option is also the most cost-effective. So already executed tests are just an example of how easy and how valuable is to use the help of the latest technology, parametric design, and integrated management platforms. On top of previously performed analysis, we can even test another final option, which is optimizing prefabricated structural elements and try to decrease size of slabs and beams, for example. So newly generated solution using predefined parametric algorithms is updated, and our project in the BEXEL manager is also updated, so we can see another change in the total cost of the project. The system recognizes changed elements since we only changed their size, but the original global unique ID for each element is unchanged, and respectively the schedule is updated, so we can instantly review 5D simulations. In the end, when we tested multiple design versions for what-if scenarios and decided on the final solution, investors can also test various scenarios which are extremely valuable when it comes to planning investments and tendering contractors and main contractors as well. So we can easily just test the final solution and test the final schedule in case if the working week is, for example, 5 days, and when the working week is 6 days. So by simply switching the calendars, entire cash flow is changed. The results can be compared with the previous design options or previous schedule versions as well. By exploring multiple options, we're just trying to find the best solution for a specific project. But in the end, this is just the beginning of the next stage of the project and project design development. Important thing is that all created or exported project information are saved within the platform and can be exported into multiple formats for analysis. One of the very interesting is integration and the ability to export all data into Power BI and create interactive and publicly available reports. The look and the level of presented details in these reports can be fully customizable, and templates are open to adjustments. In this presented workflow, I try to explain so everyone can understand what are the steps for setting up the system and creating auto-generated schedules and 5D analysis to efficiently find the best design solution. The next level of this workflow is by using BEXEL Manager command line application, which enables full automation of any time-consuming or repetitive process. So now no need for users to even open BEXEL Manager platform itself. Instead of that, we can schedule tasks and actions that we want to perform, and the system will execute all these actions according to predefined plan. It's customizable and can perform multiple analysis on a different groups of IFC files from different projects at the same time. It means that you don't even need to open your projects anymore. The system will do everything for you, and now the teaming generative design tools and integrated BIM management platforms such as BEXEL Manager, we're really reaching the next level of automation in construction industry, leaving design and management teams enough time and freedom to be creative, to be more satisfied, and to be more productive on their everyday works. Thanks for watching, and hopefully I've interested you to our new workflows and technologies and our BIM platform as well. Stay safe.